All right, everybody, welcome back to QTM 200. If you're following along with us in class, we will now be going into our third week. This is the fifth lecture or fifth module, and today we're going to be talking about bivariate regression. Now, if you, like I said, are following along, every single week we've been striving toward the goal of how to make inferences about a given population from some sample of data that we've collected either observationally or through some sort of experiment. And last time we talked about how to determine if two groups within our sample that have been collected independently are different or not dependent on each other. So in the case of when we have an experimental design, we talked about a difference in means between the two groups, or when we talked about the two variables that were not randomly assigned, right? We had observational data. We were talking about using contingency tables. Today, we're going to go a step further and we're going to talk about general correlations and associations between two variables, i.e., how similar are the data? Does variation in our explanatory variable x help explain variation in the other variable, in this case, our outcome variable? And we'll move from just basic correlations to bivariate regression. We'll only talk today about the assumptions that we need in order for bivariate regression to work, as well as what estimator we're going to be using to help with the best prediction for our parameter. So I think it's really important whenever you get any data set to first just visually inspect it using a scatter plot. And what we're looking for here is we're looking for the type of form or pattern that we see that's displayed by the data, the directionality of the association, the strength, and we'll talk about what that means. And then also we want to note any outliers that may not necessarily fit this general association. As our first example, we have a strong and positive association between two different elections, the first being the percent that John Kerry received in 2004 within a given state, and then on our y-axis, the share that Obama got in the preceding election in 2008. And clearly we can see that there, again, is a strong, as in tight, around the line. If it was a weak correlation, that may be all over the place. And it's a positive relationship because we are going up from the origin toward the top right corner. Here, on the other hand, is a pretty good example of a weak and non-existent relationship, right? This is neither a positive nor a negative relationship because our best fit line is totally horizontal. This would suggest, right, that there is not only a weak but a non-association between the unemployment during an election year and then the incumbent party's vote share, suggesting that incumbents don't necessarily do better when there's low unemployment in that year. Now, I want you to keep in the back of your head, right, an association doesn't necessarily mean there's a causation. There may be some underlying factor that is essentially washing away the direct effect that unemployment might have on an incumbent party's vote share. But at least when we look at just the bivariate relationship between the two variables, we find that there is essentially a weak and non-existent relationship. This is all well and good, and we can look at scatter plots all day, but essentially we're going to have to quantify this association at some point. And we'll start off by just talking about correlation. But before we talk about correlation, we're just going to have to talk about how we assess variation in the two variables that we'll be using in order to see how they covary.